Get started, because I'm sure everyone's got places to go this afternoon. I'm Kevin Reiss. I'm from Rutgers Newark School of Law Library. I'm the electronic resources librarian from there. The title of my presentation is a RESTful web services approach to library federated search using SRU. Now that's a lot of words and acronyms, and I'm going to try and enumerate them throughout the presentation. Just to give me an idea how fast or slow I should go in different parts of the presentation, how many of you are, I guess, technical people, and how many of you are more like managers of information resources, or librarians?
Librarian.
Okay. Okay, so it's about half and half. The first portion of what I was going to talk about is a little more non-technical, and then at the end I was going to more focused on the technical side, so just to give you a warning. Start off here, wouldn't it be nice if you could search all of your library's electronic and print resources from one location? And if you could also take interesting distributed resources and integrate those with your local materials, so your users could also be led to those materials through the same path they find your own materials. And wouldn't it also be good if you could get at what's been called the deep web in a structured and simple manner, as both a programmer and as a user? The deep web would be things like institutional repositories that some other speakers have talked here, database client, things like open access journals. And I'm going to kind of walk you through a real beta application that we've done with this protocol SRU for maybe taking a step forward towards reaching some of these lofty goals. We wanted to create a real simple Google-like entryway into all of our electronic resources, and we're by no means there, but here is kind of a preview of our beta application right now. Users can supply a query to our electronic resources and get back, a simple results page that tells them how many matches to their query are available in our various collections. And I'll talk a little bit more about our content later on. The point behind this project was we wanted to increase the visibility of all our library resources. We wanted to provide a common search interface to our growing resources to our users, because right now, to get at them, people have to go to several different interfaces. We've got to go to our library catalog to look at our catalog materials, go to our digital library site to do any searching or browsing of our digital library collections, and then potentially just kind of got a small start on this, but try and integrate external resources from the web and the academic internet. I guess the academic internet is referring to things like institutional repositories, people who are self-publishing their materials on the web. And the reason we wanted to do this was, another overriding goal for this project was we needed to use an open source solution for cost reasons. And I also wanted to use open source and open standards to be compatible with some of the emerging digital library standards that you may have heard of, things like OAI, which some other speakers have addressed here. And also this is kind of something, for me, trying to bring our digital resources so they would cooperate with some standards has made them a lot more friendly to me, the programmer of this project, so that's been an added benefit. The solution was to work out a federated search protocol. And the protocol that I've tried to do the sample application with is what's called the SRU protocol, the Search Retrieve URL Service. And I've implemented our sample search engine using open source Perl and Python modules that others have worked on to implement the protocol, and kind of tied it together in some scripts on our website. Basically, it lets users search different collections and resources at the same time, and it provides a complementary, what I call a complementary search interface to the single application search interfaces that are users typically use now, like the library catalog page, our digital library page, and this is really not a replacement, of course, because it's a very simple type of search that users can run from that page that I just showed you earlier. But it's a complement to these. We see this as kind of leading users to explore our resources further. We also, I also think that the goal of creating a federated search, kind of to take the long view of it, I think implementing standard search and retrieval protocols can benefit all consumers consumers, providers, authors of information, because this will allow people to easily address content and get content and improve the visibility of resources for all parties involved. Why should you care about something like the SRU protocol? I think for those of you who are directors of organization, I think putting out software that supports open standards and protocols gives you a better return on your investment. It will be easier for your technical people to produce some interesting applications with the resources you have, things that you've invested time digitizing, software that you've purchased to manage your library collections. And I think like I mentioned earlier, you can kind of start bringing the academic internet to your users. For web developers and masters, I think this is an interesting protocol, and some other assorted standards with it that can bring down implementation barriers such as time and cost. And I think in particular with the SRU protocol, since it's done in XML, it can kind of let you provide a customized interface of search and retrieval results for your users using XSLT. And I give a simple example of that later on in the talk. For people that I would call library technologists, people like myself, an electronic resources librarian, or maybe even a technical services librarian, learning about SRU could help you improve the accessibility of the deep web to your users. It could also let you learn about its descendant of a familiar tool that you might be familiar with, Z39.50, because the SRU protocol was derived from Z39.50. So SRU, it's a web service. You've heard about web services in an earlier presentation, so I'm not going to go through this in detail, but basically I see a web service as something that facilitates communication to a networked application. A client requests something, the server carries out the request and reports success or failure to that request, and the responses, and sometimes, as we'll see in a minute, the requests are encoded in XML. Basically, a web service lets a programmer embed a call to that service as a part of a useful local application. It could be something like querying an online database to bring those results into your website. It could be receiving news updates. It could be receiving stock quotations. That's another example of a web service that I've heard of. And so to go to the rest of the title, the REST, the acronym that was in my title, stands for Representational State Transfer. Now that's a technical description, first described by this individual, Roy Fielding, in his PhD dissertation, but in practical terms, REST has come to be a design philosophy for a kind of web service. And REST is kind of based on the fundamental concept behind the web. Basically, it posits that each URI is a unique state of a particular resource that's transferred from a server to a client that requests it. Now, what that means in practical terms, a RESTful web service, as opposed to a SOAPful web service that I think Elmer spoke about, a SOAP-based web service yesterday. A RESTful web service is always communicated over HTTP. And the request part of a RESTful web service takes the form of a URL with the query string and the parameters for that particular service. So for example, here is a URL of a fictitious web service. Just states the URL and then 2 query parameters. And then when you send such a request to a RESTful web service, the response comes back in XML defined for your particular application. So here's some real simple XML that could potentially be spit back to that URL that I just showed. It's just echoing the query and showing a simple results list. So what's the difference between a RESTful web service and a SOAP-ful web service? And that's not my terminology. Eric Morgan, who's a digital library developer, classified web services into those 2 categories. But basically, the difference is a SOAP web service can travel over something other than HTTP. It can also travel over HTTP, but a SOAP web service could be transported using email, SSH, Telnet. And a SOAP web service is encoded in the SOAP envelope, which is a kind of a message wrapper for your actual content of whatever request you send to the service. An example of a SOAP-ful web service is a Google API, which lets you query Google search index and bring those results back into your program. A RESTful web service only transports over HTTP, and instead of enclosing the response in a SOAP XML wrapper, it just serves up the application-defined XML. So now, to get to the heart of the program, what are SRU and SRW? SRU is called the Search Retrieve Web Service, and SRU is the Search Retrieve URL Service. And they're sister protocols. They do exactly the same thing. They accept the same parameters, return their results in the same XML, only SRU is the SOAP-ful variety of the protocol. SRW is the SOAP-ful variety of the protocol, and SRU is the RESTful variety. For my implementation, I've worked with SRU, the RESTful variety. And basically, SRU and SRW are a standard way to search any internet information resource. If you set up an SRW or SRU server, which is relatively painless with the modules that people have developed, you can accept queries and return search results according to this standard format. For the librarians here who might, or other information professionals who might have heard of Z39.50, SRW, SRU comes out of what they're calling the Zing group, which stands for Z39.50 International, the next generation. I don't know. So this group has defined some interesting standards, including SRW and SRU, for dealing with this problem of searching internet information resources. It hasn't hit critical mass, I guess what you could call critical mass, like technologies like OAI or RSS, which are getting widespread adoption. But I think it's an interesting piece to the possible future development of the web in terms of digital libraries and search and retrieval applications. So for an example here, I'll show you, this will kind of illustrate what the difference between a SOAP and a RESTful request is. Here is an example of a response to an SRU server, SRW server, with the SOAP information around the actual response to your query. And as you can see, the SOAP envelope can get a lot more complicated on more complicated web services, but there it is wrapped around the response. In the RESTful variety, SRU, just the application-defined XML. No SOAP wrapper. So that's really the only difference. So a basic SRU server. Oh, do you have a question?
Yeah.
Sure.
Is it inherently limited to qualified DC responses, or can I have my own schema?
No, it's extensible.
Okay.
There's actually, the SRU only has 3 operations. It only has 3 functions that you can send to it in a request, in addition to other parameters. There's, well, I have it on a later slide, but there's,
Fair enough.
that's okay. There's a small group, so I don't know if people are you know, feel free to stop me at any time. The SRU server, you create your user interface, and when the user specifies a query to that, you need to send it to the SRU server in this format called CQL, which is called Common Query Language. It was also developed by this Zing group as a query language for this server, and it's pretty straightforward. And you know, there's a spec for it on the Zing site. At the end, I've got a link to various resources on these topics. So if you're interested in looking further at them, so basically you send your query as a parameter on your URL for an SRU server, and then you receive the structured XML response back, and then you take your result and you can format it for your users using XSLT, or you can do something else with it. So just to talk a little bit about CQL, the idea behind CQL was to combine 2 search engine traditions. One, the simple Google-like queries that most users are familiar with using Internet search engine, and expressive and powerful query languages like the original Z39.50 query language or SQL XML query language. But don't worry, if you're actually interested in playing around with implementing these, you don't have to write a parser for that query. People have already done it for you. There's some Perl modules for CQL and Python modules that will accept the format and send it to your index. So here's some examples of the types of queries you can specify with CQL. A simple keyword query, New Jersey statute, or you can also query indexes that have been defined by an SRU server, and it'll do Boolean queries. So here's a query: description equals governor of New Jersey, and description equals ethics. But I don't think that one returns any results. But I guess that's a local joke. And then it can even get as complicated as specifying things like proximity operators that you might be familiar with, Lexis and Westlaw. But the key, one thing to point out is if you want to try an SRU implementation, you don't have to support this whole thing. You just have to fail gracefully when someone sends something in a query format that your implementation doesn't support. Our application is still pretty raw. I mean, this is a very beta application, but here's a advanced search interface that we provided to our SRU server. It just has a place for the user to place their query. It tells them the first record that you want back, tells the server how many records you want at a time. And then I've added an application-specific parameter to let the user choose which collection they want to search at. And the test server that I've put up was inspired by an implementation done by an individual in the Zing group that's on their website that is available under Creative Commons. So I took that and modified that to fit around our indexes and library catalog. So to send the basic parameters of an SRU request, there's the operation parameter, and this tells the server what it's supposed to do. There's only 3 types of operations that SRU servers support. There's the search retrieve operation, which is the probably the most important one, because that is the one that you send a query to the server and you get your results back. There's the explain operation, which you could think of as the documentation operation. You can define there's an XML vocabulary for defining your SRU service. It lets you tell lets you document types of things like what metadata formats your service supports, what search indexes that you can search on, like say one index you can search on the title field, another index you can search on the title, description, and the date field. It lets you express those sort of things. There's the start record. The version parameter tells the server the version of SRU XML that you want back. Currently that's 1.1. There's the start record parameter, first record you want back, maximum record parameter, how many records you want back at any one time, and then the record schema, the metadata format that you want back. So here is a URL of a full SRU request with all those parameters. Notice it's a search retrieve operation. And the standard also lets you add parameters, application-specific parameters. It just says that if you add application-specific parameters, you still have to provide something to the user if you don't, if they send a query to your server that does not include an application-specific parameter.
So I'm assuming that if I send this thing the explain word, the response I get is structured enough that if I'm kind of a dumb, or actually rather a smart client out there, I can look at what I get back from that and say, okay, this thing supports the following record schema, so I know what
Exactly.
I have there,
Exactly.
and it supports the following additional defined operations, and so forth and so on. I mean,
Yes, yes, that's the purpose of that.
So explain is not some blob of text, it's in fact a highly structured response that's telling you about capability.
Yes, yes. It's there's an XML schema for that response, and it has another long acronym that I have another slide that I cannot remember. There's too many acronyms here. So I've defined an application parameter called collection that just accepts the ID value of our collection. So I didn't have to put the same script in 10 different directories or work out some kind of URL rewriting scheme. Although that might have been a better approach given another presentation from yesterday. And so that gives you back something like this. It's a structured XML format. There's the standard defines a DTD, or actually it's a schema for this format. And our indexes are real simple right now. Right now I'm just sending back the identifier and title of our resources. And all our indexes, except for our library catalog, are indexed using the Swish thing. So right now I'm the Swish-E indexing engine, which is an open source full text indexing engine for text formats. So I'm just dumping back the Swish information. So that's and what do you do with this in terms of practicality in an implementation? You take XSLT. There's a style sheet parameter that lets you use XSLT. XSLT stands for Extensible Style Sheet Language Transformations, and XSLT is a special kind of programming language that lets you transform into XML into other document formats. So for example, you could take an XSLT style sheet written for this SRU response and then apply that style sheet to your response and get a nicely formatted HTML page for your user. And there's a style sheet parameter that lets you specify the URL of the style sheet you want applied to this. And this is where I think you can get into some interesting stuff, potentially providing different views of your data for different users, because you can have multiple style sheets for the type of user. If you have some knowledge of your user, maybe conceivably you could have a student view and a faculty view for a record. But if you're going to use XSLT, you want to keep in mind that you can take a client-side approach or a server-side approach with XSLT. My rough application here just uses the server-side or client-side XSLT support approach, and I will say that truthfully that's probably unreliable for a production level service because anything older than 5.0 is not going to support XSLT, and there's slightly different variations in the XSLT engines for Firefox and Internet Explorer, so you can get a little hairy. If you're serving up moderately sized XML documents, I think that Serverside XSLT is the way to go. And if you're a developer, Perl, especially if you use Perl, there's some nice Perl modules for the live XML, XML parser and XSLT engine, which are probably the state of the art in terms of open source, in terms of speed, XSLT. So here, I've taken an XML response and applied a simple style sheet on it to generate this HTML for our users. And then I've also, one step further, I've created kind of a wrapper script for the SRU server to send queries to multiple collections at once, and then get back those the SRU results from the query from all those collections, and then collate them into this overall view of all of our collections. Now, there's probably a better way to go about this, a much more focused way to provide, I guess, a more coherent entry into our resources, because I don't think probably breaking each individual collection down is maybe the way to go, especially with our digital library, because we have we have 8 or 9 digital library collections, each of a different topic, and it might be better to kind of work those into 2 or 3 top-level categories to bring people into them. But that's this future work. The current collections that we're indexing are just an index of our electronic journal and database subscriptions, our law library website, our digital library collections, and all of these collections are indexed using SWISHE, which is a flexible and useful open source indexing program. And then our library catalog, the British Library has done some work with this protocol, and they created a Python class to kind of wrap around a Z39.50 server that could take a query expressed in the CQL language that I talked about and translate that to something that a Z39 server could understand, and then have that also translated back to SRU, so you can use that in your application. And that uses a Python library called Zoom, as well as a Python library for parsing the CQL language. And these are all open source tools. I will say if you're go ahead.
I just had a question about indexing. I know I'm just misunderstanding you, but when you talk about using SWISHE to index your collections, is that just your local material? You're not indexing the digital content that you subscribe to as well?
No, I'm sorry. Yeah, I should be clear. Maybe in the future with some protocols, but yeah, right now I'm indexing HTML and XML files, some text files of our collections.
Your own property.
Yeah.
And then you do a search that, like a collective search, searches your own property as well as multiple digital resources that you subscribe to. It can do one place of search across all of these entities, is that right?
Yeah, in kind of a rough form. I mean, it doesn't do any attempts at merging the results for the user.
I was going to ask you about that. You're implying that the SRU server is acting as a kind of aggregator.
It could, but you have to.
And my question is how much and how.
It's really kind of it could serve as an aggregator. It's really more of a tool to show what you've aggregated. Okay. So say if you're harvesting OAI data, for example, and you have these 10 or 15 subject-specific collections that you harvest, keep them updated. You could put an SRU server around that to deliver search results.
So, but let's keep it simple for a moment. Assume that I'm running 8 collections out there that are indexed using SWISHE in some way or other. How is the SRU server looking at the SWISHE indexes? Is it simply learning the file system for them? Is it assumed to be coexistent on the same box? How do I tell my SRU server that I've got SWISHE stuff sitting there? How does it look at it?
Right now, I'm probably. I don't think Swish cannot go across multiple. It has to be on the same, or at least the same machine, right? Because the simple implementation that I've done for SRU takes the query and then it uses the Perl Swish API module to actually look at the physical index and get the results back, and then parses it into that
Is that a
format.
glue script that you wrote, or is that something that it does out of the box?
It's really it's a glue script that I wrote, but the thing that was really helpful is the CQL parsing module that I worked with. It has a function to take a CQL query to something that Swish can understand. So you can just create your object-based object class, and then you just create your object, and then you say, okay, query to Swish, and then send that result to the Swish.
When you talk about result merging or the lack thereof, so I've got 3 Swish indexes that are sitting out there that this thing knows about and can talk to via the glue script. Does it make any attempt to merge those relevance lists when it pulls all 3 of them back, or? I mean,
Not on the
naively assuming comparable scoring and all the indexes.
I kind of was experimenting with that last week before I came here, just by merging my Swish indexes beforehand and then pulling them back. I will say that I don't know. Probably maybe some of the technical people here have worked pretty extensively with Swish. I don't know. Have you tried to do any large-scale merging?
The entire U.S. code.
Okay, because I ran into problems with the properties.
Yes.
That was a real headache, and that's why I wanted to demonstrate that here, but I kind of ran out of time.
I'm just curious about how the aggregation function works, because for us that would be the big.
The draw for something like this. So it's really kind of self. There isn't anything really built in to it. So here was my application diagram. I've got Swishy indexing content in our digital library website, and potentially some OAI harvested data. And then I've got Python wrapper sitting around our library catalog, and then the user submits a query in the form of a URL with the appropriate parameters to the server. That server spits out the XML response, and then we reply the XSL style sheet to it, and then send the user back some HTML. So now to get to the explain operation, it serves as, it tells a programmer about your SRU server. So if someone is interested in using your data, this response tells them about what you've indexed. It tells them what fields are available to search on. It tells them the metadata sets that are available. It tells them the default parameters for your server. Things like, by default, your server will return the first record and 10 results at a time. There's also a third operation called scan, and I haven't seen any implementations of this there's probably on the Zing site. There's about 15 SRU implementations. I didn't see any that implemented the scan function, but the idea behind scan is it's an index function, so potentially it could display the control vocabulary for your collection and show you how many records are relevant to this vocabulary, this term in the control vocabulary. So for example, here is HTML formatted version of our of an explain request to our SRU server, and it's a real rough implementation, but just shows things like a simple description of the server, URLs that are related to it, the location of the SRU server itself, contact information. It's a screenshot. Can't scroll down and show you the different indexes, but basically it says, okay, you can search on the title index, you can search on the description index, you can search on the date. So I think that this could fight what I would call search engine Babel. I don't know if you ever tried to use multiple search engines, maybe try and do some integrated or common collating of their results. Consider the following query. At the top is how you'd send that query to our library catalog server. The next one is how you would send that same query to Google, then Yahoo, and then bpress. As you can see, to collate all of those, you have to get the query syntax and the UR parameters for that right, and then you not only have to do that, you have to then take your HTML output and scrape those pages to get your response information. So that isn't really a really reliable solution. You know, the search engine could change the way it's HTML formatted and break your script. But something like SRU, doing that would be very easy, almost trivial. So imagine if a lot of resources supported something like this. It would be easy to bring users search results from targeted SRU compliant applications or resources. And some things that I had in mind for exploring future SRU application was to try and incorporate content from possible indexes and resources into federated search if things like, say, Google Scholar or something like that supported this parameter, supported this service. Or another thing I had thought of was to use SRU to kind of build what you could say subject-specific search interfaces to a particular topic. If software like institutional repository software or blogging software or software that people are using to self-publish works supported this type of searching protocol, you know, you could take those SRU compliant resources and, you know, build them into some interesting presentation on a particular subject. As a demonstration of that, a real simple demonstration, you can use the Open Archives Initiative harvesting protocol to, you know, harvest data from people that from resources that are complying with it. So if you wanted to maybe provide an interface to that OAI data, SRU could be an interesting protocol for you. And also, one thing, OAI does not support full-text search, but SRUW could potentially support full-text search. So you could harvest your OAI metadata, and then if the repository allowed, you could also harvest the full text of those materials available and then present them back in an SRU, SRW form to the user. So I think they're kind of complementary protocols. And I think, like I said, then you could easily search harvested OAI data via SRU. And one thing that Tom actually mentioned in passing yesterday, imagine if you know, one could harvest things like court decisions via OAI. It could be very easy to you know, get decisions from your state courts or your local courts who are publishing them, and then use SRU to present a search interface to that data. And if you're interested in exploring OAI further, I recommend that you go to the University of Illinois website, where they've got an OAI registry of compliant OAI data providers, and you know, see if anything there interests you. I looked. So this is how I see OAI and SRU complementing each other. On the right here, you've got all your OAI data providers. You know, many. You know, it could be 100, 50 data providers, and then you have a couple OAI harvesters that go and periodically get content and make sure that you've got all the new content from those OAI data providers. And then you could provide an SRU server that is wrapped around those OAI harvesters to do the search and presentation of that OAI data. So, for example, the NELCO Legal Scholarship Repository, which another speaker showed earlier, it's a scholarship. A scholarship repository from the New England Law Consortium that complies with OAI. So you can harvest the information from there. So what I did is I harvested the records from the repository. I created a switch config file for those harvested records. I indexed them. You know, I created an explain record so that the collection could implement the explain operation of SRU. And then I gave it an ID value in our federated search application. I made the index a new search target. And this is what something like Google Scholar is doing when it's indexing institutional repositories like DSpace, which supports OAI. So Google is going and harvesting those OAI records, including in its scholarly index. Oh.
Okay, I'm a tad confused.
Okay.
When you're talking about this plan that we have on the screen at the moment, is the idea that OAI harvests the metadata records? Is it then that you are indexing the metadata records themselves with Swish or access via SRU, or are
Yes.
you reaching back to the URIs contained in those metadata records to do full text index?
You could potentially do that, but actually this particular repository, I chose it because it was a legal material repository, but they actually have a note in their OAI registry data that do not use our data without our, do not index our full text data without permission.
So just to be sort of an idiot about it, why would you not just use an RDBMS for the metadata records? And do you have good hooks into RDBMS type applications with SRU the same way you do to Swish? Is there glue there for that?
No, I haven't done that part yet. But conceivably you could, and it would not be too difficult.
Probably fungible in terms of
Yeah.
forms, right?
Yeah, I mean, if you were using vast amounts of data, probably the DBMS would be better.
My mind was sort of going off in the direction of like Paul and circuit boards.
So just here's that simple search interface again, and then choosing the Nelco scholarship repository, sending a query to the server, and we're just getting a result back from that remote resource. So I think what can libraries gain from this? I think it can improve discovery of institutional and remote resources. Potentially you could do some subject-specific aggregation of things on the academic internet using something like OAI. You could provide user context-sensitive display of resources using XSL. And I think this kind of fits in with something I found interesting. I don't know how serious you are into digital libraries, but this individual, Roy Tennant, who's done a lot of writing, he's from the California Digital Library Project. He's kind of advocating that libraries, I guess, move into the 21st century on digital library applications. A quote from him is, we must be able to accept and deliver multiple forms of metadata in order to build scalable digital libraries. And I think that using protocols like SRU and OAI that are open, and in the case of SRU, pretty extensible, and OAI is extensible as well. You can represent multiple metadata sets in OAI. Kind of go a long way to helping institutions start moving forward with their digital libraries. And now I think I'm just open it up to questions. If you like, I could add some more material about some different web services, RESTful and non-RESTful web services, just kind of background information. So thanks for taking the time to listen to me. Yeah, I'm sure rather and also add, if anyone can remember the title of my presentation, I'll give you a free ticket to the Cubs game versus the Red Sox today. Because I can't remember it. Oh, I'm sorry. Go ahead.
No problem. I have a couple different questions. One, in that user interface, it kind of demands at least a bit of syntax or knowledge.
Yeah, no,
Has that been a problem in terms of adoption by your users?
Yeah, I should have actually put a slide up of our future plans for this. This was presentation here was kind of detailing my own exploration of the protocol. We haven't had a chance to, other than other staff who have tested this, we haven't released it to our students and faculty yet. So I'm hoping to present a much more fully featured interface in the fall.
Okay, that would make it easier to.
Yeah, that would handle, you know, if they wanted to do a more sophisticated query, like on a particular field, rather than just a keyword search, it would, you know, handle all that behind the scenes.
This is some very cool stuff, and the question I have is, what range of capabilities does the SRU server have in terms of talking to back-end index? I mean, we know how to talk to Switch, we know how to talk to Z39.50 servers, or somehow.
Anything.
What else you got?
That's it for now. You know, I mean, it's still a beta application. I mean, I have a long way to go to presenting something that'll do real robust error handling, for example.
When you go to do that interfacing between the SRU server and some kind of back-end header and some sort of back-end resource, I mean, is there a sort of well-understood, well-documented API for doing that, or are you?
No, the SRU applications, it's pretty well defined in terms of the parameters that you can send it and what you should send back, but really, other than that, it's completely open. What you do once you send that data to the server, you just have to send it back in that XML format.
Okay, so it basically says, you say to your SRU configuration, okay, I've got a script over here that's going to send you XML according to some well-understood schema that it specifies. Basically. Suppose I want to write a blue script. What do I have to do?
Well, I mean, in effect, that's what I did. I guess what I'm calling my SRU server is really just a glue script that is.
Okay.
Yeah, I'm sorry if I didn't make that clearer. You know, there's a Perl module for parsing the CQL query, and then I'm using like the Perl module for Swish, and then just have a CGI script that accepts the query, sends it to the query parser, making sure that it's a valid query, and then using the parser actually is nice enough to provide a method that'll take you right to Swish.
Okay, so
and then
both goes on over my head. I was assuming that you had installed something called, Joe's SRU server.
No. Well, I mentioned I kind of got the idea to try this out from an example script that was on the Zing site, and the code is there. It's real. I mean, it's that server was only like 200 lines of code. But basically, you just have in my script, I have a search swish function, and you could just if you could implement a searching function that could go to any type of information resources you have, a DPMS, or so even something like one of the XML indexing tools might be an interesting thing to work with.
One of the great beauties of OAI is that it's quite easy to write applications that sit on top of stuff like case management systems in courts, which is what first got me thinking about that. And I presume the same would be true of SRU from what you said.
Yeah, I mean it's a relatively simple protocol. I don't know if it's gotten a lot of traction yet. I know this version 1.1 came out last spring, and there's some. It seemed like that actually the European library was kind of trying to do something with it on a large scale. I didn't see anything from the U.S. On the project website, I've got links to probably about 9 or 10 articles from like Digital Live magazine, or what's the other? I think the European version of that. Some people. Well, thanks for listening to me. I hope.